This is Saxon Advanced Math Lesson 98A. This is change of base. Remember that logarithms work for any positive number except for 1. We can use as the base for a logarithm. And so they have example 98.1 here. It says find log 515. Now this would be a little more difficult to find. Of course, I think we already know how to do this. If we set this equal to the y and then say, well, okay, if I find the logarithm of both sides, and that is going to be the preferred method. But we're going to show you another method where we can use our calculator. Some of you are going to like that because it's less work because you like to use the calculator instead of the rules. This right here is going to be very simple. We do have to change its format. So we're going to say y equals a log 515. We're going to use y as our variable. And then I convert the format. Remember, this is my exponential, so 5 to the y equals 15. And that's really what we're looking for when we're saying log 515. We're saying 5 to what power equals 15? Well, and I think we can figure out that obviously 5 to the 1 power is 5, that's too low. 5 to the 2 power is going to be 25, that's too high. So we know it's going to be between 1 and 2. But let's go ahead and work this out. So we have two ways we can do this. We can use base 10 or base e. Most of you will probably use base 10 because, hey, we think in base 10 much more easily than base e, but that's okay. It's the same number of buttons on the calculator. So I get this log, or 5 to the y equals 15. I take the log of both sides, right? So log 5 to the y equals log of the 15. Remember that exponents can move out. Now I get y log 5 equals log 15. At this point, I divide both sides by the log of 5, and I get y equals log 15 over log 5. Now I'm ready to just use the calculator. So I find the log of 15, which is 1.1761, and find the log of 5, which is 0.69897. And then I simply divide the two of them, and when I do so, I get 1.6826. So log 515 equals 1.626. Now what is that saying? That's saying that 5 raised to the power of 1.6826 equals 15. And I would suggest checking that at least mentally, realizing that it has to be between 1 and 2, so it does work out. It is a valid answer. But if on my calculator, if I hit the y to the x key, so I'll hit 5 y to the x and then put in 1.6826, or use the little raise to key, the caret key, whichever one you want to use, and that is going to show you that that is correct. Now if I use the same thing with base e, and I'm going to skip some steps, I can jump right from this step to this step, right? Instead of doing them in the middle. So y ln 5 equals ln of 15. And I divide both sides by ln 5 and get ln 15 over ln 5. Well, ln 15 is a real number. Ln 5 is a real number. When I do those, I divide them and I get 1.6826. And I left these off because you're going to do the same thing. You're going to leave that on the calculator to get this. Once I know this, 1.6826, log 515 equals 1.6826. Guess what? It's the same answer. Now look at 98.2. Find log 782. So really what I'm doing is I'm asking 7 raised to what power equals 82? Well, if I looked at it and said, well, 7 squared is 49, 7 cubed is obviously too big. It's going to be between 2 and 3, right? That's pretty easy to figure out. So I go ahead and take this and take the log of both sides, right? So when I do so, I'll end up with log 7 to the y equals log 82. Move the y out to the front of the log, so y log 7. Divide both sides by log 7, so I get log 82 over log 7. Now I plug those in the calculator and I end up with 2.2646. And this allows me to convert the base, if you want to think of it that way. And that's what this lesson is about, is converting it from a known base and getting that base that was not fun to work with out, converting it to base 10 by using the log of both sides, or base e by using the ln of both sides, and that allows me to convert or change the base into something my calculator recognizes right off the bat, and I can now say 7 to the 2.26 or 2.2646, which give you about 82. Of course, there's going to be some rounding differentials there. But this is pretty easy to work with. The biggest thing, the keys to this is, for this problem, is that you have to remember how to convert from exponential logarithmic and logarithmic to exponential. And remember one rule of logarithms, and that is exponents become coefficients.